Hey there, my name is Alejandro, and welcome back for day 78 of me doing the Daily LeetCode challenge after I reached 1 year's worth of green contributions here on GitHub. So today's problem is for October 2nd, 2024, and let's get straight into it. Okay, today we got LeetCode Easy, problem 1331, rank transform of an array. Given an array of integers r, replace each element with its rank. Okay, the rank represents how large the element is. The rank has the following rules. Rank is an integer starting from 1. The larger the element, the larger the rank. If two elements are equal, their rank must be the same. Rank should be as small as possible. Okay, let's look at an example. So 40, 10, 20, and 3. Okay, 4, 1, 2, and 3. 40 is the largest element, 10 is the third smallest, 20 is the second smallest, 30 is the third smallest. This is a LeetCode easy? Okay. With its, ranking in terms of like how it deals with each other in sorted order. Okay, so what are the constraints? 10 to the 5. So n log n still technically works. So we could do something like sorted array is equal to sorted r. Then for d is equal to, we'll do plus 1. Was this d, or for I in range length of r, we'll do, okay, d of r of sorted r of I is equal to I plus 1. Ooh, and okay, if things are tied, then they should be the same, right? So the point is like, okay, I'm trying to come up with like, the simplest solution possible, where it's like, okay, you essentially want to rank things in terms of like how they compare against each other in terms of numbers. So it's like the larger the element, the larger the rank. So it's essentially like you sort everything and you give it everything a rank starting from 1, right? So the ranks, I'm going to guess the smallest possible rank you can give is 1, right? So yeah, rank is an integer starting from 1. Okay, cool. Okay, so the only thing we have to think about is essentially if things are the same as well, right? So, right. We'll do rank is equal to 1. Then we'll say for num in sorted array. Okay, prev num. Okay, so the first number will give it a rank of 1, right? Okay. Current num is equal to sorted array of index 0. Then we're going to say that sorted array of 0 is now equal to a rank of 1, right? And then our rank might still be 1 depending on the other thing, right? Now we're going to say for num in sorted r. We want to, yeah. Actually, we're going to do for I in range length of r, but starting from index 1, we're going to say, okay, if r of I is equal to r of I minus 1, or actually if it's not equal, then we're going to augment the rank plus or equal 1, rank plus or equal 1. And whatever this number is, we're going to say sorted array of 1, of I, sorry, is equal to the current rank, right? And then we return sorted array. So something like this should work. Okay, can't access rank. Okay, did I not? Okay, so I didn't initialize rank to 1. Okay, so we initialize rank to 1 here. Okay, so this does not work. Oh, yeah. I have to remap them in the order that they were back in, right? Right. Okay. Or you know what? I can even do something simple. Okay. So I'm just running through my idea. Worst case, I will explain how I came up to my solution once I'm done with this problem. Okay, so we can go through the sorted array. Essentially, it's like, okay, we sort the array right now to make our lives easier, and then if there is a solution that we can do without sorting, we'll try to come up with it, right? But for now, we might as well do the simple n log n solution, because n log n will definitely work on something like 10 to the 5. Because log base 10 of this is equal to 5. 5 times 10 to the 5, which would be n log n in that case. In the worst case, would be 5 times 10 to the 5, which is less than 10 to the 6, which is allowed on LeetCode, so that would work. So sorting works. Now the only thing is like, okay, so essentially we want to give each number a mapping of a rank, right? So num to rank, or we can call it SRD, right? So num to rank mappings, right? And so essentially we're going to do for num and sorted r, or for I, okay, for I in range length of r, rank is equal to I plus 1. Num is equal to r of I. D of num is equal to min of d.get num, comma rank and rank. Return an array of d of num for num in r. Does something like this work? It does not work. Okay, so let's print d. So I mapped 40 to 1. Print sorted r. Oh, I want to do sorted r of I here. That's my bad. Ah, okay. Okay. There we go. Okay, so this guy doesn't work now. Why? Interesting. So in this case, what is the smallest element, right? Is it 5? Right. So 6. So 5 I gave a rank of 1. What did I give 6? 6 never got a value? Or, oh no. Wait, this doesn't make sense. Right, so it equals this. So I'm doing the minimum. That way it's like, this is interesting. We want 5 and then 3. So these represent ranks. What's the second smallest element? So yeah, this is the smallest. So where's 2? So it's the 4th. So 9. So I have my 2 here, and I have my 1 here. Then I have my 3 here. Then where's my 4? The point is I don't have 4. Why? That's interesting. That's interesting. So I skipped 4. Why did I skip 4? Print rank, comma num, comma d. So I have a rank of 1, 2, 3, 4. Right, so 12 happens twice. 12 happens twice, but when I keep going and so on, the other elements will have been shifted, right? Right. So I'm not actually accounting for that, right? Okay, so I gotta do a better job. So essentially, yeah. So the point is, again, when there's duplicate elements, that's what's gonna mess things up, right? So that's why I was trying to do the previous solution here. Or, you know, instead of this, I could do d of, so I could do the same thing here, right? So num is equal to sorted array of I. D of num equals mean of d dot get num and rank, right? And this d of 0 sorted array of 0 is equal to 1. Something like this. This does not work. Oh yeah, I'm returning sorted R. So return, again, this idea. This does not work. Print D, comma, R. So yeah, these are numbers. Oh, so I have 1 here. Oh yeah, because I set this before I did that. Yeah. Okay. Actually, I don't want to do this anymore. It doesn't actually matter. Still skip the 4, eh? Oh, sorted R. That's another mistake. Okay, so now we have it passing. All right, let's try submitting. This index out of range. Okay. Right, because I do this stuff. Length of R is less than or equal to 0. Return an empty array. I think it might just be that case, literally. Okay, there we go. We pass it. Nice. Okay. All right. Are we just shy of the other? Okay, yeah. So it seems like we might be just like unlucky submissions here. So okay, let's just do this. All right, let's optimize this a little bit, right? It could also be that, okay, since we're sorting, we might be a little slow. Let's figure things out, right? So okay, now we can remove this. I'll be able to explain my solution. This will be very nice. So okay. So yeah, this is sorted array. No. So if I use something like a heap, it doesn't help, right? Right, because again, it'll be just n log n operations, right? So like this is n log n. Now heap idea will be n log n. Okay. Otherwise, let's fix up the code here. So current num is equal to this. So d of sorted r of 0 go to 1, right? And that's why, like, if we're indexing 0 and you know, like, there is nothing, like, no index 0 to index, and that's why we were failing the case. Okay, so now d of, we don't do that. So this is the initial thing. Here we can do return map lambda num comma d of num r, just to be a little bit faster. Okay, I make a lot of references. Okay, let's submit this again. Okay, 9%. So we are kind of slow. We're not in this category of things. Okay, so maybe there is an O of n way to do things, right? Is there any like follow-ups or anything like this? Seen this in a hint? Okay, so there are hints as well. I wonder if, okay, I want to check if there is an O of n way to do it. I also don't want to get spoiled by if I look at the hints, right? So that's not something I want to do. Is there a way we could do this in O of n time, essentially? Give an array of integers. So essentially you want to give each element a rank. Okay. Also, we could do something like this. If num num not in D, actually we could do something clever. D of num is equal d dot get num, and otherwise if it's 9 there, right, we give it the legit value of rank. So something like this would work. Let's see. Or not. I thought it was like, okay, if num is not, if it's already in there, it'll be the smallest one, right? Oh, otherwise, yeah, rank plus or equal 1 here. Or actually, since I already did case 1, I'll do rank plus or equal to 1 here. But that's essentially the problem. Is it not? Oh, I rank plus or equal, yeah, okay. If num not in D, D of num is equal to rank plus or equal to 1. Right, and now we do this. Or is it, okay, I'm just trying things here. Okay, so let's think about it, right? If it's the same number, right? If num is in D, then continue. If num in D, continue. I'm trying to do this a cheeky way. Otherwise, it's like, why bother, right? Okay, so I'm just doing it the wrong order there. Right, so essentially this is fine. So rank plus or equal to 1. Or can I do something for num in R? Okay, sorry, I'm just trying to be cheeky here. So here we'll comment this guy out. Can I get away with something like this? Oh, sorted R. Right, and if I put this here. Ah. Okay. And what if I did D is equal to this? Okay. And if I did rank equals 0. Okay. Yeah, okay. So rank equals 1. Okay, there we go. So now we have it as clean and chic as can possibly be, right? There we go. So we can get rid of this. Just a little bit of trial and error there. This makes sense though. Rank equals 1 for num in sorted R. Right, so something like this. So this is as nice, clean, and concise as our solution gets. And if this is, so okay, so we're consistently slower than the rest of the crowd, right? So essentially what this tells me that there's probably an idea to do this in O of n time, right? So the question is how? So the point is, it's like, okay, you want to have relationships, right? But it's like, essentially, it's like, it's as if though you have to sort. It's like, I'm kind of like right here with the crowd, right? That's what kind of worries me, where it's like, is it just because I'm doing this and that's inefficient and so on? Or is there an actual O of n way to do this, right? That's what I really want to know. So the point, yeah, you do want to map things to things, right? The point is like, okay, if I give 40 a mapping, like a rank of 1, and then I see that 10 was valid, right? And it's like, oh man, 10 should actually be 1. And then I update all the values before me. Like this ends up being like an n squared solution, right? So it's like, how would you know that the rank of a certain number is without sorting it, right? Okay. Okay, I think it worries me, like, why are we slower than the crowd, right? So it's like, if I resubmit, it's not like it's just random milliseconds and then we'll end up here, right? Oh, okay, maybe it is. Okay, so 34% and so on, and so, okay, maybe we are, right? So 250 here is, yeah, we're like right next to the 237, right? Okay, so we're starting to get a little fast. Can I do this any faster? Probably not, right? It's just weird, like I'm consistently still like in this bottom third. That's what worries me. But am I being slowed down because I'm doing something like this where I'm mapping the values at the ends? Okay, I want to take a look at the hints and just see what they say, right? Because I wish there was a follow-up here, or like something that tells you whether it's like the optimal solution is n log n or O of n, right? Because it's like, if there is an O of n solution, I want to come up with it, but I don't want to make like, spend like 1 or 2 hours trying to come up with an O of n solution when there isn't one. So let's look at the hints and see what they say. Use a temporary, okay, to copy the array and sort. Okay, the rank of each element is the number of unique elements smaller than, the rank of each element is the number of unique elements smaller than it in the sorted array plus 1. Ooh. Okay, so this is obviously what we did. I wonder if hint 2 is because it's like there's another idea, right? Let's think about this. The rank of each element is the number of unique elements smaller than it in the sorted array plus 1. Okay, well that's true, right? Okay, in the sorted array. What if we did things figure? Okay. Rank of each element is the number of unique elements smaller than it in the sorted array plus 1. Of course. I guess, okay, maybe that is just the optimal solution. I wonder, why is it so slow? Is it just that there used to be like less test cases before? Because it's like, I'm not even using like, like Python list comprehension. I'm literally using map, right? Or, okay. Ooh, wait. Okay. So the number of numbers that are smaller than it below, right? So it's like, what if everything like starts with a rank of 1, right? And it's like, oh, I gotta think, right? Or it's like, maybe I populate a dictionary, but I don't build a sorted array. And it's like, give everything in a rank of initially 1. And it's like, if I go along array, right? everything is initially 1. Then I have something like 37. Any number that's smaller than 37 should have its rank augmented by 1. But yeah, no, I get into n squared territory. Okay, I think like, yeah, if you try to be cheeky, you'll just get into n squared territory. Okay, and this is what the hint status do and so on. We can check, okay, let's look at the editorial and let's just look, let's not look at the actual solutions, just the running times and see if there's any that are, okay, so this is time of n log n plus s, whatever I said, I don't know, I don't mind. Okay, n log n O of n, I don't care what the solutions are. N log n. Okay, so all the solutions are n log n. Okay, no worries, no worries. Okay, then that means we have an optimal solution. Okay, very nice. We have an n log n solution and so on. There we go. Bada bing, bada boom. That's all we needed to hear. Okay, then that makes me a little bit more confident and happy. So as always, in all my videos, I do a little explanation of how I was able to solve the problem. So here in this problem, essentially, you just want to map each number to essentially its rank. And its rank is kind of like, okay, rank number 1 belongs to the smallest number, right? Rank number 2 belongs to the second smallest number, right? So it's essentially, it's like you're mapping each number to essentially like the position in a sorted array that it would be in, right? The only caveat is that if there are duplicate numbers, then they should each have the smallest, they should each have the same rank, right? So it's like if you have something like 1, 2, and 3, and 3, and 4, then it's like this should have the smallest rank, this should have the second smallest rank, these should both have the third smallest rank, and this should have the fourth smallest rank, right? So that's essentially all that I'm saying. So here all I did is like, okay, first of all, if the array is empty, then just return an empty array, right? That's pretty straightforward. Otherwise, we're gonna keep track of a hash map and a default rank of 1, right? Rank 1 is what we're gonna initialize to the very first number, right? And all we're gonna say is like, okay, for each number in the sorted array, right? The smallest number in the sorted array should have the rank of 1, right? So let's go through this like step by step. If num not in D is initially empty, right? So we initialize D of num to be equal to rank, right? So the very first number in a sorted array will be equal to a rank of 1, right? Then I augment rank by 1, right? And essentially it's like, okay, if this is my array, right? I'm essentially, if this is my array, right? Python 3, and this is my array, then the very first thing that I'm going to do is sort it, right? So we're looking over the sorted array, right? So r.sort, right? And for each of these, I'm going to give this a rank of 1, right? So let's loop over this, right? So if I have array is equal to this, and, well, sorted array is equal to that, and then array is actually equal to this guy, right? Okay. Whoops. Okay. So my array is equal to this. Sorted array is equal to this guy. All right. So here's what I'm doing, right? It's essentially at the very beginning, D is empty, right? And then I'm going through every number in sorted array, and if the number is not in D, right, then I set its value to rank, right? So essentially, the very first number inside of the sorted array will have the default starting rank of 1, right? So the rank are numbers that start from 1, essentially rank numbers from smallest to largest, but if they're duplicate numbers, they should have the same rank, ideally the smallest possible rank for each and every single one, right? It's like kind of like if like, you know, in swimming, like one person finishes in 10 seconds and then the other two finishes in exactly 12 seconds. There's not a first, second, and a third. There's a first, second, and a second, right? So it's like 2 second places because they at the same exact time. So that's kind of the idea here, right? So think of rank as like, you know, placement, right? So like first place, first rank, or second place, second rank, right? And it's like in terms of swimming finish times. So something like that. So the very first number here that we're going to have 5 is going to have a rank of 1, right? It is the absolute smallest number. I don't care if there's duplicates about it. It's going to have a rank of 1. In the sorted array, the smallest number will have a rank of 1. So that's all I'm doing at the very first iteration, right? Then the reason that I check if num is not in D, well, okay, we can go through this and continue on. So the second number in sorted array is a 9. It's not in the dictionary, and rank is now 2. So we're going to set 9 to 2 and increment rank to be plus 1, right? So rank is equal to 2. Now we plus or equal to 1. So it's now equal to 3, right? And then here, 12 is not in the dictionary, and so we're going to add 12, and it's going to have the rank of 3, and now rank is going to be equal to 4, right? But here's the thing, we're going to go to 12 again, right? So 12 should be, it should still keep the same rank of 3, right? So when I get to rank is equal to 4, and I come in and I loop over 12 again, I don't want to give it a value of 4 again, right? The point is it's already been given a rank of 3. So essentially, if the num is already in the dictionary, I've already given it a rank that has to be smaller than the current rank that I'm at, right? Because each iteration, if anything, I either do nothing to the rank or I increment it, right? So if it's already in the dictionary and I've already assigned a number a rank, well, that's already the rank it should be, right? Because the way that we break ties, you give it each duplicate number the smallest possible rank that they could be, not the largest possible rank that they could be, right? So it's like this is rank 1, this is rank 2, and these are supposed to both be rank 3, right? And if there's like 100 duplicates, they're all rank 4, right? So essentially it's like 12 is already of rank 3. When I get to rank 4, I don't want to reset 12 back to 4. So a way I can do that is, okay, if the number is in the dictionary, right, then I am not going to update 12. And I'm also not going to augment my rank value, right? Because it's like, as long as I keep going through 12s until I get to this 28 here, I don't want to keep augmenting rank, right? Because the next rank to assign is the rank of 12 plus 1, right? So that's why I only say, like, if the number is not in D, then set D of nums is equal to rank and augment the rank, right? Otherwise, it doesn't matter how many 12s I'm going to go through, since they're all already inside the dictionary with a valid rank of 3, I'm going to skip all of them and not increment rank, right? And so the next time that I get to increment rank will be when I get to a number that's not in the dictionary, like 28, in which case I will set 28 to that rank of 4. And again, rank will be plus or equal to 1 because this is the next rank that is assignable to a value, right? If I have a bunch of 28s, right, like this, 28, 28, 28, 28, 28, it doesn't matter. They're all in dictionary, so they're all going to get skipped. The point is that you want to keep skipping over the ones that already exist, right? I guess a small optimization I could make is if I make array into a set, right? So that way it's like I don't consider duplicate elements, right? And maybe I can do something like this and submit. Okay, and so now we're already getting faster. Okay. Okay, that's actually really nice. Okay. So this is essentially the same idea, right? If I get completely rid of like the duplicate numbers inside of the array, then essentially I just have to give them each a mapping, right? So it's like the sorted version of each of the numbers without the duplicates. I'm essentially going to give each number that rank and then increment rank by 1. So I think this is even easier to understand, right? It's like, okay, first thing, let's get rid of all the duplicates inside of an array, which we can do by turning an array into a hash set, right? Sorting that hash set, right? And so that way, it's like if we take something like this, where it's like, okay, the very first thing we're going to do is convert it to a hash set. So this is, we're going to get rid of all the duplicates in there, although it might not be in sorted order. And then this will be like a hash set, but then again, when we call sorted, it will be back in sorted order. So we'll have something like this. And then the problem becomes very easy, right? So 5 should have a rank of 1, 9 a rank of 2, 12 a rank of 3, 28 a rank of 4, and so on, And then what we return is essentially like, okay, let's go through each number in array and essentially map each number to its actual rank, right? So D is essentially, D of num essentially represents the rank of a number, right? And I essentially have found the rank of each number. So that way I might as well just say like, hey, okay, I'm gonna call the map function, right? So this does the same thing as, you know, return D of num for num in R, right? So it's just the map function for functional programming in Python, just to make things a bit even faster. But the point is I'm transforming every number in an array. I'm returning a new array, right? I'm not actually transforming the values in an array, but essentially I'm returning an array with mapped values inside of it. Instead of having for each number, I convert it into D of number, right? So I'm returning a whole new separate array where the values themselves are transformed from number into D of number, which represents the rank of that number, right? So maybe I should have called this like, you know, if I do D num to rank. Right, but okay, I'll just keep it D so that it becomes a bit nice and cleaner syntactically. There we go. But essentially, yeah, so these maps numbers to their ranks and so on. So it's like, okay, map each number to their rank of array, and that's what we return, right? So it's essentially, it's like, okay, if we do here, 5 is rank of 1, 9 is rank of 2, 12 is rank of 3, 28 rank of 4, 37 rank of 5, 56 rank of 6, 80 rank of 7, and 100 rank of 8. Then essentially it's like I'm transforming each of these values in an array into their rank. So it's like, okay, I want the same order as array, so let's look at this. Okay, 37, what does 37 map to? It maps to 5, right? So let's do 5. What does 12 map to? 12 maps to 3, so let's do 3. What does 28 map to? 28 maps to 4, so let's do 4. What does 9 map to? 9 maps to a rank of 2, so let's do 2. 100, what does it map to? It maps to a rank of 8, so let's do 8. 56 maps to 6, so let's do 6. 80 maps to 7, so let's do 7. 5, what does 5 map to? 5 maps to 1, so let's do 1. And what does 12 map to? 12 maps to 3, which is 3. Even though 12 was a duplicate, again, we gave that a singular rank, and this is our final solution. And what you'll see is if I come in here into the solution, this is the exact solution that we want, right? 5, 3, 4, 2, 8, 6, 7, 1, 3. 5, 3, 4, 2, 8, 6, 7, 1, 3, right? So that's essentially how that algorithm works, right? So essentially, I sort the array. That way, I sort the hash set version of the array. So I convert the array into a hash set so that I get rid of duplicates, right? I then sort that array, and then I give essentially each number is equal to a rank. Ooh, I could even. Yeah, okay. This is, I thought of a new idea. But essentially, it's like I give each number in the sorted array, like, okay, if you're the first number in the sorted array, you have a rank of 1. The second number has a rank of 2, right? Because again, there cannot be duplicates because we converted this into a hash at the very beginning. So we only have unique numbers. So essentially, it's like, okay, the first one, we give it a rank of 1, the second one a rank of 2, and so on, because we already have them in sorted order because we just sorted it, right? And then we want to return array with the map values as their ranks, right? So it's like essentially we just return a mapping of the array itself, whatever numbers were there, but we map the numbers into the rank that we computed this way, and that's essentially our final solution. So I hope that kind of makes sense. So we can run our solution here one more time. Maybe with the set thing is a little bit faster now. That's something I realized. Okay, so we're still in this range and so on, but our solution is indeed n log n because of the sorted part here, which we saw from the editorial. We checked the complexities of the solutions in the editorial. They're all n log n, therefore us having as an n log n solution is optimal, even though we're like only beating like about 30% of the solutions here on LeetCode. But I hope that explanation made sense, and otherwise, that's pretty much it for this video. If you did find it useful, I would highly appreciate if you left a like or a comment. As always, as I promise in all my videos, if you do leave a comment, I promise to respond to every single one of your guys' comments, because I love having one-on-one chats with you guys, even if it's not LeetCode related. So whether you want to talk about LeetCode, CS, or something not CS or technically related, 100% feel free to leave a comment, and I'll make sure that I respond to every single one of you. But otherwise, that's pretty much it for this video, and I will catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.